Okay, welcome back. In our last lecture, 2.3, we pulled back the curtain slightly on the core technologies powering much of modern AI, simplifying concepts like machine learning, deep learning, and neural networks. We saw that these are powerful methods for teaching machines to learn from data. Now, in lecture 2.4, we're going to use that understanding to categorize AI into different types, specifically distinguishing between what exists today and what is still hypothetical, narrow AI versus general AI, or AGI. Understanding this distinction is absolutely crucial for having a realistic perspective on the AI landscape and avoiding the misconceptions we discussed in Module 1. Much of the confusion and sometimes fear around AI stems from conflating what current AI can do with what hypothetical future AI might be able to do. Let's start with the type of AI that is prevalent, powerful, and impacting our world right now. This is called narrow AI. It's also sometimes referred to as weak AI. The key characteristic of narrow AI is that it is designed and trained to perform one specific, well-defined task, or a very limited set of tasks, extremely well. It specializes in a particular area and can often outperform humans within that narrow domain. However, its intelligence does not extend beyond that specialized task. It cannot take the learning or capabilities from one task and spontaneously apply it to a completely different one. Let's look at examples of narrow AI, and you'll quickly realize how integrated they are into our daily lives. The AI that is exceptionally good at playing chess or Go and can beat the world champions, that's narrow AI. It is designed specifically for that game's rules and strategies. It cannot suddenly write a novel or diagnose a medical condition. The AI behind spam filters, trained to identify patterns in emails that indicate spam. It's very good at that specific job, but it can't navigate a city or hold a conversation. The AI that powers recommendation systems on platforms like Netflix, Amazon, or Spotify, trained to predict what products, movies, or music you might like based on vast amounts of user data. It's specialized in predicting preferences within its dataset. The AI used for facial recognition, trained to identify faces in images or videos. It's narrowly focused on visual pattern recognition for faces. The AI that enables virtual assistants like Siri or Alexa to understand spoken commands and respond to simple requests. These systems use various narrow AI components, like speech recognition, natural language processing, and information retrieval, to perform specific tasks like setting timers, playing music, or answering factual questions. They don't truly understand context or engage in complex reasoning like a human. The AI components in a self-driving car, specialized systems trained for specific tasks like identifying objects, pedestrians, other cars, traffic signs, predicting their movement, mapping the environment, and controlling the vehicle's acceleration, braking, and steering based on its programming and sensor data. While complex, these are still specific tasks within the domain of driving. The AI isn't simultaneously managing the car's finances or writing poetry. Even the cutting-edge generative AI models we see today, like those that generate text, ChatGPT, Bard, etc., or images, DALL-E, Midjourney, Stable Diffusion, are currently considered narrow AI. While they can produce remarkably creative outputs across a wide range of styles and topics, they are specifically trained on massive datasets of text and images to perform the task of generating new content based on patterns they've learned. They don't possess consciousness, real-world understanding, or general intelligence outside of this generative task. They can't suddenly decide to learn a new skill, like riding a bike or playing the stock market on their own. The power of narrow AI comes from its specialization. By focusing on one task, developers can optimize the algorithms and training data to achieve incredible performance within that specific domain. This is what makes today's AI so useful and impactful in real-world applications. It excels at automating, augmenting, or performing tasks that require processing large amounts of data, recognizing complex patterns, or making rapid calculations, tasks where humans might be slower or less consistent. Now let's contrast that with a type of AI that is still largely theoretical and does not currently exist: artificial general intelligence, AGI. AGI is sometimes referred to as strong AI or human-level AI. The concept of AGI is an AI system that possesses the ability to understand, learn, and apply intelligence across a wide range of tasks at or above the level of a human being. An AGI would have the capacity to perform any intellectual task that a human can. It could reason, solve problems, make decisions, understand complex language, learn new skills, adapt to novel situations, and apply knowledge across different domains, all without being specifically pre-programmed or trained just for that one task. Think of the difference this way. A narrow AI that's a champion chess player only knows chess. An AGI would not only be able to play chess, but also write a compelling essay, compose music, learn a new foreign language, understand complex social cues, develop scientific hypotheses, and engage in deep philosophical discussions, and learn how to do these things just as a human would through observation, learning, and experience. AGI is the kind of AI often depicted in science fiction as sentient, conscious, or possessing human-like thoughts and feelings, though consciousness is a separate and even more complex topic than general intelligence itself. While significant research is being done in areas like transfer learning and multitask learning to make AI more general, we are still very far from achieving AGI. There is no consensus in the AI research community on when, or even if, AGI will be achieved. It remains a hypothetical future milestone. Briefly beyond AGI, the even more speculative concept is artificial superintelligence, ASI. This refers to a hypothetical intelligence vastly smarter than the best human minds in virtually every field, including scientific creativity, general wisdom, and social skills. ASI is purely speculative and represents a potential future state after AGI is achieved. Why is this distinction between narrow AI, the reality of today, and AGI, ASI, the speculation about the future, so important for our preparedness? Firstly, it helps ground our understanding in reality. Most of the AI you interact with, the AI impacting industries, and the AI driving current economic and social shifts is narrow AI. Understanding its specific capabilities and limitations is vital for practical preparedness. It prevents us from getting overwhelmed by hypothetical fears of superintelligence taking over tomorrow and allows us to focus on the actual challenges and opportunities presented by the AI systems we have today. Secondly, it helps us assess risks accurately. The immediate risks from AI, as we discussed in Lecture 1.3, come primarily from the misuse, unintended consequences, or biases within narrow AI systems deployed at scale, not from sentient AGI turning malicious. Focusing on the distinction allows us to address the real and present dangers more effectively. Thirdly, it clarifies the path for human roles. The rise of narrow AI highlights the increasing value of human skills that are not narrow: general intelligence, adaptability, creativity, critical thinking, emotional intelligence, and ethical judgment. Preparing for a world with powerful narrow AI is largely about enhancing these broader human capabilities and learning to collaborate with specialized intelligent tools, rather than preparing for a world where a single general AI replaces all human intellect. In summary, today's AI is overwhelmingly narrow AI, highly specialized systems performing specific tasks. Artificial general intelligence, AGI, the ability to perform any intellectual task at a human level, is a future hypothetical goal. Understanding this distinction is fundamental to navigating the AI landscape effectively. It helps us appreciate the incredible power of specialized AI today, while maintaining a realistic perspective on the future of general intelligence. With this understanding of the different types of AI, we have one more foundational concept to clarify in Module 2. In our next lecture, 2.5, we'll clear up the confusion between AI and some related terms you often hear: AI versus automation versus robotics. Thank you for joining me for this look at the types of AI. I look forward to clarifying these related concepts with you in the next lecture. Enjoyed the video? Want to stay up to date with the latest GMP insights and guidance? Then make sure to subscribe to our channel. We've got tons more helpful content coming your way. Hit that subscribe button and join the GMP Guide community.